Hello everybody and welcome back to the channel. In the previous video we looked at a variety of fractals, from classic fractals such as the Sierpinski triangle to creating unique custom trees like the ones you see behind me. Today we will be looking at creating a custom biome with these trees and implementing them into Minecraft's terrain generation. Without further ado, let's get right into it. So this is what we currently have. A floating tree which we can summon in with a complicated command. And this is what we want to end up with. Custom biome with many trees spread out far and wide, with no input from me. So how did we get here? The first step was to find a way of generating custom trees. Luckily, I was able to look at the Fabric modding documentation to get a simple example of a custom tree. With this, I was able to add in my own strange diamond block trees into the game. A good start, right? Little did I know how much worse this was going to get. Now we have custom trees, we also have to create a custom trunk placer. To understand what a trunk placer is, let's look at this example tree feature. It's composed of four main elements. We have the wood block, our trunk placer, our leaf block, and our foliage placer. The trunk placer is what actually places our wood blocks, and is how we create our tree. We're going to ignore the foliage placer and leaf block in this video, as we can handle that all in the trunk placer as well. All I'm doing in the code is overwriting the vanilla trunk placer and replacing it with our fractal version. We can use the algorithm I made last time and get it to return a list of all the blocks which need replacing. Now in the trunk placer, we can loop through all those blocks and use this line of code to set them to be a log. Simple. Or is it? Now let's take a look at them in game. So on the whole, it looks like it's working pretty well. So let's take a look around. But this seems to be a bit of a problem. So as you can see, our tree is getting clipped. And more specifically, it's getting clipped at a chunk border. Let's take a look and see if we can find any other cases of this. So as we can see right there, there, and there. So clearly, this is quite a common problem, and it's definitely something we're going to need to fix. So it looks like Mojang has coded in a hard cap on how wide our custom trees can be. Brilliant. But surely there's a nice easy solution to this. Right? After scrolling through forums for ages, I found no easy solution. So back to the drawing board, I guess. First, let's diagnose the problem. What's going on here is that the setBlock function has a finite range. We can only use it in chunks in or neighboring where the tree is spawned. So one idea is to simply make the trees smaller and place them in the center of the chunk, to minimize any edge effects we see on bordering chunks. I don't like this very much though, since it means we can't have our giant trees. Let's look at idea 2. Instead of the blocks getting cut off, why don't we add all these removed blocks to a list, known as a buffer, and simply add them in later. This seems a bit overkill though, right? And surely we can figure out something using Minecraft's default methods. Using said default methods is option 3. We can make our tree a custom structure. Since these can be quite big, I doubt they'll have the same limits as our custom tree, right? Okay, you get the idea. Coding can be painful, especially with modding a game without the greatest documentation. After spending hours creating the trees as a structure, here's the result. 0. Literally 0 difference. It has the exact same problem. So it looks like we're going with option 2. So where do I begin with this idea? First, we want to take all the block positions generated by our fractal algorithm and store them into a list. We can then place these in a special data structure known as a hashmap. Hashmaps are a very useful data structure within computer science. Let's explain them using this treasure chest. When we use our standard key, we get a value, which is our diamond. What makes this interesting though is that if we use a different key, such as this skeleton key, then we get a different value. This means that each value within our treasure chest will have its own unique key that can be used to access it. This is the same in our hash maps, where each value has its own key. This makes it really quick to access values we want and makes it very useful here. What I've done is use the chunk position as our key, with the corresponding list containing all the blocks to edit for that chunk. Then later, when we load in a chunk, we can grab the corresponding list of blocks and simply place them in the world. This will make loading the chunks slower, but seems like it's going to be the only practical option. I won't bore you with any other technical details, but feel free to check out the source code linked in the description of the video. Now to testing this method. It works! Finally, it looks like we've managed to incorporate our fractal trees into the game. Now let's address some of the issues with the trees. For this, let's take a look at some of your thoughts and suggestions in the comments on the previous video. Let's take a look at this first suggestion from Malaise. One thing I think could enhance this would be less density in the canopy. The trees we got at the end created so much shadow, when in reality at least some light would usually permeate the leaves. This is a very valid concern and is very noticeable when I don't have Fulbright on. As you can see here, the bases of the trees are very dark. To fix this, I've created a new leaf block. Here you can see the standard oak leaves compared to the new light leaves. These new light leaves on the left have no shadow. Hopefully this will make our trees look less dense and remove some of that shadow at the base. Let's add this to the trees so you can see how it looks. It's quite easy to see the difference here as the bases of the trees are much brighter. Let's compare them side by side to make it clearer. With that problem sorted, let's move on to the next comment. This next comment is from Moonwatch, saying, I think an interesting idea could be to create a similar function to make the roots of the trees, to make them look more natural by both expanding up and down in those really cool fractal ways. Roots, now that's a fun idea. To create roots, we're going to need a few extra rules and symbols in our L system. To quickly recap how our tree spawning works, we're generating our trees using an L system, which uses a collection of rules and symbols to create our fractal. In the base rule set, for example, we have a collection of rotations and forward symbols, which result in our tree. For our roots, we'll need to come up with a new additional rule set. Let's look at one I came up with in a test world. This isn't a bad start, but let's take a look at a few more attempts. Before making this video, I never realized how wide tree roots really are. Unlike how they're traditionally depicted, they can actually spread out 2 to 4 times the diameter of the crown, which is the widest part of the tree. In fact, they don't even go very deep at all. Instead, they usually spread out along the surface. With that in mind, let's take a look at some other root attempts. Many of these attempts look quite similar, but what I was trying to do here is to flatten these roots out so they stretch more horizontally than vertically. At the same time, I did want some vertical variation as well, so they weren't so flat. Now we've got some realistic looking roots, let's take a look at them in our biome. Well, it seems the roots don't exactly match the terrain the tree is placed on. Since each one of our trees is generated by the same algorithm, they're not going to be responsive to if our terrain has mountains or hills. One way we could try fix this is to only spawn our trees on flat ground, but I think that'd be a bit boring. This problem is otherwise quite difficult to fix, and creating natural roots is definitely beyond the scope of this video. For our final mod, I'm going to leave these roots out. Even though they're quite fun to play around with, I don't think they're going to work for this mod. Let's take a look at this next comment from Fundam Srijan. So it looks like this comment is focusing on the width of the trees. Finally, a suggestion which is easier to fix. All we need to do here is adjust the starting thickness and branch decay. In fact, I'm also going to add some randomness here, so we can get a little bit more variation in the trees. Okay, now this is pretty awesome. Let's fly around and take a look at some of these larger trees. Now that the trunks are wider, they've stopped looking as bush-like as before, and have started to look like real trees. Why don't we try increasing the thickness even more? Now this is a pretty big step up from before. You can see that most of our trees are actually breaching cloud height, which is quite funny. One thing that's really noticeable at these larger width is the radius decay. This means that each step is quite visible, but I don't think that's an issue. Well, I'm really happy with how these larger trees look. While I won't choose a radius this large for our final trees, I think the one before looked really good. And yes, I would say that we've got one step closer to making Avatar in Minecraft. Let's take a look at one more comment. This one's from Young Suit. It looks like this suggestion is focusing on the spacing of the trees, and I like this idea, as it'd be nice to spread the trees further out in our biome. as trees in real life have to compete with each other, so are usually not this close. Without getting too technical, I added a minimum separation between the trees, which surprisingly isn't something configurable by datapack for some reason. Looking at you, Mojang. Now we should have a nicely dense forest without our trees located too close to each other. With this change made, everything looks so much more realistic. It just feels like you've been shrunk down. Now that we've learned how the mod was developed, let's take a look at it in-game. While I wander around and explore the biome and survival, I thought it would be a good time to talk a bit more with you guys about developing the mod and what to upload in the future. So this mod took a lot of time to make, mainly because of how tedious it can be to make things like this work in Minecraft. I think the end result is great, but it can take a while to load when generating new chunks. Even after spending lots of time on the project, there are a few bugs I haven't been able to iron out. I won't keep the mod private for any longer though, as I know some of you would like to have a play around with the mod and test it out for yourselves. The source code will be linked in the description, and I'll also leave a link to the mod download on Modrinth when that comes up. With that said, thanks for watching, and if you enjoyed, please consider subscribing.